Hey there! Today we're going to pull back the curtain on our digital world and decode the fundamental language that powers every single piece of tech you use. Yep, we're talking about the secret language of machines. I mean, really think about it for a second. Your phone, your laptop, your gaming console, they all do these unbelievably complex things. But at their very core, deep down inside, they're only using two symbols, a 0 and a 1. So how on earth is that possible? Well, that is the big secret we are going to unlock right now. So here's our game plan. First, we'll start with something familiar, our everyday numbers. Then, we'll dive into the computer's light switch language. After that, we'll check out some other cool ways to count. And finally, we'll wrap it all up with a quick quiz to see what's stuck. Let's do this. All right, first up, let's talk about something we use so often we don't even think about it. It's the number system we use for, well, pretty much everything. Okay, before we get any further, we need to get one key idea down, what a number base actually is. The best way to think of it is like this set of building blocks you have for counting. It just tells you how many different digits you can use before you run out and have to start a new column. You know, like going from the ones place to the tens place. So, the system we all know and love is called decimal, or you might have guessed it, base 10. The name kind of gives it away, right? We have 10 unique digits to play with, 0 all the way up to 9. Once we hit 9, we're out of single digits. So what do? We pop a 1 in the tens column and reset the ones column back to 0. And bam, we get the number 10. You've been doing this your entire life. Okay, and now for the main event. Let's peek inside the machine and learn its native language. And you might be surprised to find out it all boils down to something as simple as a light switch. This, my friends, is binary, also known as base 2. Now, if base 10 has 10 digits, what do you think base 2 has? Yep, just 2, the famous 0 and 1. And believe it or not, every single thing a computer does, every video, every game, every message, is communicated using just these two numbers. The absolute best way to wrap your head around this is to just picture a light switch. A 0 simply means the switch is off, and a 1 means the switch is on. That's it. That's the whole secret. Off and on. But why? Why this super simple system? Well, it's all about physics. Computers run on electricity, and their circuits are made of billions of tiny microscopic switches. Each one of those switches can either have electricity flowing through it, which the computer reads as on, a 1, or not, which is off, a 0. So base 2 isn't just a choice, it's the natural language for electronics. So when a computer sees the binary number 101, it's not thinking 101 like we would. Nope. It's just reading a super simple instruction. The first switch is on, the second switch is off, and the third switch is on. It's that simple. Every photo, every song, it's all just a really, really long string of these on and off signals. Now, as you can imagine, writing out millions and millions of ones and zeros would be, well, pretty boring for us humans. So clever programmers came up with a couple of handy shorthand systems to make their lives a whole lot easier. First, you've got Octal, or base 8. It uses, you guessed it, 8 digits, 0 through 7. This was useful because each digit in Octal can stand in for a group of exactly 3 binary digits. It just makes those long strings of ones and zeros way easier to read at a glance. But the real big one, the one you'll actually see out in the wild, especially for stuff like color codes on websites, is hexadecimal. That's base 16. Now wait, if we only have 10 digits, how do we get to 16? Well, this system gets creative. It uses our normal digits 0 through 9, and then it just borrows the first 6 letters of the alphabet. So here's how that works. In hexadecimal, after you count to 9, you don't go to 10. Instead, A stands for 10, B is 11, C is 12, all the way up to F, which represents 15. It's a super efficient way to represent a block of 4 binary digits with just one single character. So if you've ever seen a weird code for a color like #FFFFFF for pure white, you're looking at hexadecimal. That's just a shorthand way of telling the computer to turn the red, green, and blue light switches all the way on. All right, let's just put it all together in one place. We've got decimal, our everyday base 10. Then there's binary, the computer's native base 2. And we have the programmer's handy shorthands, octal and hexadecimal. At the end of the day, they all do the same job, representing numbers. They just have a different number of digits in their toolbox. Phew, okay, I know that was a lot of info, but the core ideas are actually pretty simple. So how about we do a quick quiz to see if you've cracked the language of machines? Ready? All right, first question. What is the base of the binary number system? I'll give you a second. Got it? If you said base 2, you are absolutely right. It's called base 2 because it only uses 2 digits, our good friends 0 and 1. Okay, question number 2. Thinking back to our trusty light switch, what does the digit 1 represent in binary? And the answer is on. It represents an active electrical signal, the switch being flipped on. And for our last question, what value does that letter A represent in the hexadecimal system? Think about it. After 9 comes A, so A represents the value 10. If you got that one, you are totally nailing this. So look, if you take away just one thing from all of this, let it be this: our entire complex, amazing digital world, every app, every photo, every bit of it is built on one incredibly simple idea. A switch is either on or off. That's it. So there you have it. You've just learned the fundamental alphabet of all modern technology. This is the language that's used to build everything from your favorite game to the software that might just take us to another planet someday. So the only question left is, now that you speak the language, what are you going to build with it? Thanks for tuning in.